Hello, this is Joe Fitzpatrick here. I'm going to be in this video going over the interactive advanced concept presentation number 7, the magnetic fluid or the ferrofluid. So in this experiment, the materials, there weren't too many. The materials needed were, you need a tiny earth magnet, which I got here, a little magnet, and vegetable oil. Here's the vegetable oil container with the oil top. And for measuring purposes, I used a tablespoon, regular tablespoon, to measure out the vegetable oil that I go on to add into my solution. And also, you need the black ink toner, which is right here in this mason jar. You can kind of tell, super black at the bottom with the ink toner. And then it's a tinted blue colored mason jar. So basically getting into the video, my experiment did not really work, but I have a pretty strong hunch as to why exactly it didn't work. I think it's sort of a culmination of some things. One thing I thought of was the earth magnet that I chose right here. It's not super weak, but it's just not extremely large. And so maybe a larger magnet could have helped. Also, the solution itself, the mixture of the black ink toner with the vegetable oil, I might have made mine too thick or too dense. I mean, that's a possibility. So it just wasn't able to get those individual needles forming. And also, one thing that I thought about that could be a factor, could not be, but also the mason jar that I had laying around to use, it is somewhat on the thicker side. It's kind of hard to tell, but the glass itself, it's just a pretty thick build to it. So that could, all these sort of could come together to form a reason as to why my experiment didn't work. But so I'll still just get into the experiment itself. What should have happened and why it should have happened. So starting off, in order to make the ferrofluid, I started off by pouring about 50 milliliters of the black ink toner into the colored mason jar. And then I added roughly 2 of these tablespoon measurements of the vegetable oil right here. And I added that into the mason jar with the black ink toner and mixed it for roughly probably about a minute or so, and then I sort of just let it sit for a minute or so as well. And then so I went to go and test the ferrofluid. And so to test it, I used my earth magnet right here, and I basically went around the bottom and on the sides of the mason jar to see if the ferrofluid would be magnetized and produce the needles within the mixture. And the needle-like structure in the ferrofluid is what is shown in the initial video posted on our assignment page on our school website. And that is what I was looking for in my mixture. And yeah, like I said, I was not able to see a whole lot of that. And again, I explained why. I think it may have been a culmination of a couple things. But regardless, I'll still get into the experiment here. And so basically going on to talk about what we did in this experiment. Ferrofluid itself, it is a liquid that, when it's formed, contains tiny magnetic particles, which are called nanoparticles due to their extremely small size. And its magnetic properties actually come from the magnetized iron oxide that it contains. And so normally its magnetic properties, or normally the tiny magnets within the ferrofluid would run into each other and just sort of stick together and bunch up. But due to the increased surface area within the liquid itself, the magnets don't bunch up at all. And so that allows the liquid as a whole to keep its magnetic properties while not just bunching up into a solid shape. So once a surfactant is bonded to a nanoparticle, it gets considered a ligand, and this ligand also has an attraction to the carrier fluid, which is what pulls it towards the magnet, the magnetic force that is coming from an outside magnet presented like right here. And so this is basically what is done in the experiment to a T. You know, the experiment with the black ink toner, vegetable oil, and earth magnet. You have the ferrofluid and you have the outside magnet coming in to try to pull the carrier fluid away, creating those needles. And so the experiment kind of self-explains. The spikes in the ferrofluid on the magnetic field lines create those needles that we saw in the initial video posted, and that's basically the ins and outs of the ferrofluid itself and what is supposed to happen and why it's supposed to happen. I think the reasons I noted in the beginning of the video of why my experiment didn't work, those might combined. Those might, make a pretty big impact on why my ferrofluid just didn't show those needles. But regardless, it was a pretty cool experiment. Definitely was able to learn a good deal about magnetic properties, and even though I wasn't able to see it firsthand in my kitchen, it was pretty cool to do the experiments. And also the video posted on our assignment page, it was really cool to see because you sort of put the text to the video as far as seeing what's happening. So overall, really cool experiment this week. And yeah, I'm just looking forward to next week's experiment and seeing what we get into next week. But that is all for the interactive advanced concept presentation number 7. Thank you.